Welcome to section 2. In this section we'll be looking at the hash tables and binary search trees. So we'll be looking at the hash tables, hash functions and binary search trees. And this is a first video of our second section, and in this video we'll be looking at the hash tables and hash functions. So how to do a fast lookup of our data. We will answer a question of what a hash table is, and we'll be implementing our own hash table. At the end we'll be testing that hash table if it works as expected. So let's see what a hash table is. Let's say that we want to add some keys to our data structure, and we have keys that are following: John Smith, Lisa Smith and Sandra D. We want to group those keys into some data structures that are smaller, and we will call those buckets. So we are applying the hash function to John Smith, and it will result, let's say, in the number 2, and that key will land in the bucket 02. Then Lisa Smith is, after applying hash function, its hash is equal to 01, and it will land in that bucket. So in Java hash map we also have some kind of buckets, and inside of every bucket there is a linked list, and we will be using it as a map. So we will have an entries. Entry will have a key and value, and we are hashing only a key. So we are calculating that hash from key, and if it hash to the value 0, we will add it to bucket 0, and inside of that bucket we have linked list of all elements that keys were hashed to 0. Then we can have bucket 1, 2, 3, and we can see that lookup of that key will be fast because we will go to the specific bucket, and only within that bucket we will search linearly, but it will be very fast. And this is once again hash table presented. So we have 5 buckets, bucket 0, 1, 2, 3, 4, and we are applying the hash function for key, and if it land in bucket 0, then we will be added to that bucket. If there was not value there yet, we will create a first element, and it will be ahead of our linked list. If that value key will be hashed to 1, and that bucket 1 has already more elements into linked list, we will apply new element, add to the tail of the list. And hash table complexity is very fast if we have hash function that is proper, because search is almost 01, insertion is almost 01, and delete is almost 01, because we need to only traverse within a specific bucket. And if we have a lot of buckets, let's say 1000 buckets, we can insert many elements and still have that complexity 01. We will implement our custom hash table that will use the hash value of key and add that element to the linked list that is inside of the bucket of the hash table. So it will be a custom hash table, and we will start from writing a test. So we are creating custom hash table where key will be a string and value will be integer. So string will be used to hash that entry to the specific bucket. And we are putting the A1 entry, B1 and C1. And ideally, every entry should go to the separate bucket. So entry with the key A should go to first bucket, key B to the second, and key C to the third bucket, and so on. Then we are asserting that we have 3 elements in our map. Then getting the value for A should be very fast because it goes to the specific bucket, search that linearly for that specific key and returns it. And value for that should be equal to 1. Also the method contains key for A should return true, and contains key D it should return false because there is no such entry with such key in our custom hash table. But let's examine the implementation of custom hash table. It will work for generic types, so it's for type key, that will be a key, and file, that is a value. we need to define a number of buckets. So let's assume that we want to have 10 buckets, so we are defining that number of buckets is equal to 10. Then we need to define our buckets, and our buckets will be list of entry. So index of every element in our list will be equal to bucket, and inside of that there will be a linked list that we will need to traverse by iteration. So this is a constructor of our custom hash table, and it will look like this. So we are creating linked list of buckets, and for every bucket we are adding for the index I a new linked list. So each bucket will be initialized to the empty list. Then let's look at the put method. So we are putting key and value. Firstly, the most important thing that we need to do is to take a hash code that will be used to find the specific bucket. Then we are modulo number of buckets, and resulting number will be an index to which we will add that element. We also need the class entry. Class entry is a simple class that has only key and value, and we are just setting those and creating a getters for those fields. And once we determine the index, so the bucket to which we want to add, we can call a get method on our buckets that will return the index of that bucket. And this is a resulting bucket to which we need to add new element. But since the linked list and hash map doesn't allows us to create two entries for same key, firstly we need to delete that entry and add it again, so it will override that entry for that specific key. The size method is fairly simple. We are just iterating over every bucket. We are taking a size of every bucket and reducing that size, adding everything together, and it will return size of every bucket, sum of every bucket. The most complex method, but very fast, is a get method. So firstly, similarly to put, we need to determine the index, so the number of buckets to which we need to do a lookup. So we are using the same formula, so we are taking a hash code modulus number of buckets, and it will return the index of bucket that we need to get. And we are assigning result to the list of entries, and we need to traverse that list iteratively. So it will be n, but first lookup to take that linked list was very fast. So for every entry in that resulting bucket, we need to find out if the key is equal to key that we want to find. If it is equal, then we are taking the value and we are collecting it to list. But since this is a linked list inside and this is interface of map, we cannot have more than one entry for that specific key. So if the result is empty, we are returning just null, and if it's not empty, we are taking the element 0, one element that could be present for that. Last method that we need to implement for our test is contains key. So for key we are just getting that value, and if it's not equal to null, so if it's present, it means that this key is inside of our map. So let's look at this test and start it again. And we successfully put some entries to our map and retrieve them. We can also test our hash map in more robust way. So we are creating hash map, but we are adding 10,000 elements to it. So we are using the int stream and range from 0 to 10,000, and for each element we are just adding entry to our map. And the results should have size of 10,000. And we can see that test passed also.